Hi everyone, it's Mrs. Woodruff. Today we're going to do another geometry review. Last time that we met, we talked about the volume of prisms and pyramids that we had learned in 7th grade, and we did a review of that. Today we're going to do a review of circumference and area of circles, also from 7th grade. And our goal is to put sort of these two ideas together. In 8th grade, we want to find the volume of what I called the circular 3D shapes, the cylinders, the cones, and the spheres. But before we can get there, we're just kind of making sure that everything that we need is back in our brains again. So the information I took from this video is from the 7th grade book. So the first thing, we're going to take a look at a circle here, and a circle is a set of all points in a plane that are the same distance from a point, and that point is called the center. So if you look at this circle, all the way around, every point on the circle is the same distance from the circle to that center point. So a circle is kind of like a hula hoop. And here we have our center. The circumference is the distance around the circle, kind of like the perimeter of a circle. The diameter is the length, or the distance, I should say, from one point on the circle to the opposite side running through the center. The radius is half that distance. It's half the diameter. It only goes from a point on the circle to the center and stops. So if you look in this diagram, you can see where the center is, you can see where the radius is, and you can see where a diameter is. And I shouldn't say the radius, because there are actually an infinite number of radii, that's the plural of radius, in here, because right here I could trace another radius over here and one down here. So we're going to start first by remembering sort of the difference between that radius and diameter, and how if you have one, you can find the other. So if you take a look at this circle right here, you can see that this red line runs from one point on the circle through the center all the way to the opposite side. That would be called the diameter, and it happens to be 14 inches. I just want you to notice that the word diameter is longer than the word radius, and a diameter in a circle is longer than a radius, which we're going to see down here. So down here, notice that this little red segment only goes from a point on the circle to the center. It only goes halfway across the circle, and that's called a radius. Now, if you're given the diameter and you need the radius, you have to take that longer distance and cut it in half, divide it by 2. So if the diameter is 14 divided by 2, 7 would be the radius, and in this case, the units are inches. Notice that it is straight units because we're talking about a distance, one dimension, 7 inches. Here in this circle, I'm given a radius. It goes from a point on the circle to the center, and I want to know what the diameter is. Now, the radius is the shorter one, so to get the longer one, I need to multiply by 2, 8 times 2, and the diameter would be 16 feet. So this is just a quick reminder of going from the diameter to the radius, or the radius to the diameter. So if you have the radius, you have to multiply by 2 to get the diameter. That's what we did down here. And if you have the diameter, you have to divide by 2 to get the radius, and that's what we did right here. Now, just to kind of compare what we're going to be talking about today, there are really 2 words that we talk about with the circle: calculating the circumference and calculating the area. So if you have a pooch and you attach him to a leash and you stake that in your backyard, and he fully extends that leash and keeps running around a circle, and you'll notice that he's making kind of a pathway here. So if you want to find the distance that the dog would run with that leash fully extended, would you want to find the circumference, or would you want to find the area? So remember that the word circumference means perimeter, and that's what the dog is doing with that leash fully extended. So in this case, Adrian would want to find the circumference, and we're going to review how to do that in just a second. Now suppose instead of that, she wants to figure out how much space she's given her dog to run. So not just fully extended, but he could let the leash go slack and kind of run over here, and he could come over here, and he could come over here, and he could run inside the circle all the way around. He couldn't run out here, but he could run in all of this area inside of that circle. So if she wanted to find out the dog's running room, she would calculate the area. Remember that the circumference is like a perimeter, and that's going to be a straight distance. So your circumference, we're going to notice, is going to have straight units. And when we talk about area, we're going in 2 dimensions. Remember, we talked about this way and that way. So that's going to be in square units, area, square area. So giving another real world example of like when you might want to know the area of a circle, I immediately, of course, think of pizza, because who wouldn't? But if you wanted to compare 2 sizes of pizza and which one gives you more area, that would be an example. You know, how much more pizza do you get from a 12-inch than a 10-inch? You would want to calculate the area of both and compare them. Now, what would be an example of possibly in the real world the circumference? Well, if you were buying a hat and needed to measure your head, you'd take a tape measure like we used a couple weeks ago, and you'd put it around your head, and you would be measuring the circumference or the perimeter of your head. Okay, let's go back to that idea of the circumference. How do you calculate the circumference of a circle? Well, there is a formula, and you'll notice there's 2 here, but I've circled the one that's the easiest to remember. To find the distance around the circle, you need to take the diameter and multiply it by pi. Now, pi is not the apple or the blueberry variety. It is a Greek letter, Pi. And if you remember in my room over in the windows, there is a poster that had a whole bunch of digits of pi, 3.1415926, and it goes on forever. It doesn't repeat. It doesn't end. It's called an irrational number. We usually approximate it. We cut it off, estimate it to about 3.14. But the minute we do that, of course, our answer is not accurate. It's an approximation. So we're going to take the diameter, which is the distance across the circle through the center, and if you multiply it by that wonderful magic number 3.1415926, yada yada yada, you will get the distance around a circle. So here's an example. We want to find the circumference of a circle whose radius is 21 inches. So the first thing we have to notice is that we are given the radius. We were given the shorter segment. To calculate the circumference, I want the diameter times pi. So since they gave me the radius, to get the longer one, I have to multiply the 21 by 2 to get the diameter. So the diameter, the D in the formula, became the 42 inches. That would be the distance across the circle through the center. And then we're going to multiply it by pi. Now you might remember in 7th grade, we stopped there and we called this our exact answer. Because the minute we pick up our calculator and take 42 times the pi button, or if you don't have a pi button, 42 times 3.14, you're now going to have an approximate answer. So this is called our exact answer. And then when we multiply in the calculator by pi, it's about 131.9 inches. And notice that the inches doesn't have a squared or a cubed. It's just straight units because circumference is a perimeter and it's straight units around the shape. So let's take a look at this one, these 2 right here. Let's see if we can have a little bit of success and see if you can remember how to do that. So pause your video for a second and see if you can do both of those problems on the bottom. Okay, we're back here. So when I went to find the circumference, did you notice that you were given the diameter? You went all the way across. You were given what you need for circumference. You just need to take the diameter times pi, and you've got the distance around the circle known as the circumference. So here is my formula, and that D became the 70. That is my exact answer. That's going to be important as we move forward into volume, that you always give your exact answer, and then pick up the calculator, take 70 times the pi button, or 70 times 3.14, and you're going to see it's about 219.9 inches. Now notice that we are going to be rounding to the 10th. That means 1 decimal place. So it's about 219.9 inches. Now over here, they didn't give me the diameter. They gave me the radius. Now, I don't want to work with fractions, so if I take 7 divided by 8, that would give me the decimal approximation for 7/8. And then if I multiply it by 2, my diameter was 0.87, my radius was 0.875. That's 7 divided by 8. And I'm going to multiply it by 2 to get the diameter. And that right there is my exact answer. My diameter is 1.75 feet. Multiply it by pi, either using 3.14 or the pi button, and it's about 5.5 feet. That's how you find the circumference of a circle. Now we're going to talk about, that's like the dog running around with his leash completely tight as he runs around, and that's the pathway, the distance he would kind of ruin in your lawn. He would make that path. Okay, so let's review from last year the area of a circle. Now, what can the dog do as far as if his leash was slack? How much running room have you given him? You're now looking for how much is inside the circle. To find that, you'll remember from 7th grade that you're going to take your radius squared and multiply it by pi. You're going to notice I rewrote this. We're going to put the radius squared first because we're going to be showing our exact answer. So if I look at this circle right here, I notice that I'm given the radius. In the area formula, I need the radius. Circumference, I needed the diameter. So here I'm going to take that 2, which is the radius. I'm going to square it and get 4, and I'm going to write down 4 pi. That's called your exact answer. Now I'm going to take 4 times pi, or 3.14 if I don't have the pi button, and it works out to be 12.6 inches. And notice this time I put in the squared because I'm looking for area, and area's units are squared, area square. You see the book did it with the 3.14, and how did we get that 0.6? That 5 is greater than 5, so that's why we're going to round this 0.5 up to 6. He's going to bump him up. All right, so why don't you give these 3 a shot looking for the area? And when you go to look for the area, remember that we're going to be using the formula, the radius squared times pi. I need the shorter segment in the circle that goes from the center out to a point on the circle. Square it, not multiply by 2, square it, and then multiply by pi. Please remember to put your exact answer as part of your work. Why don't you pause the video and see how you do. Okay, when I come back and I look at a circle, I'm immediately looking for what is being asked of me, circumference or area. In this case, it's area. Since it's area, I want to use the area formula, which is to take the radius squared times pi. They gave me the radius, so all I have to do is substitute it for the r variable in the formula. This is not 10. This is 5 times 5. So you're going to notice that it is 25 pi, and that is called your exact answer. Now pick up your calculator, take 25 times the pi button, or 25 times 3.14, and it's about 78.5 centimeters squared. Now, if you use the pi button versus 3.14, the answer can be slightly different. If you use the pi button, it's more accurate because there's more places of pi than just 2. If you use 3.14, your answer could be slightly smaller. Okay, did they give us the radius over here? They did. We're looking for the area, so that 7 is going to become the r, and the a equals r squared pi. So notice there's the radius squared. Again, this is not 14. 7 squared is 49. There's my exact answer. I pick up my calculator, 49 times pi, put a round to the 10th. I only want 1 decimal place, and I'm not going to forget to put my units in. Did you get about 153.9 inches squared? The last one didn't give me a picture, but it told me that it's the diameter. Now the diameter is the long segment that goes all the way across the circle. If we had been looking for circumference, we would have been happy, but since we're looking for area, we're not. So we have to start by realizing that we need to take this long segment and divide it by 2 to get the shorter radius. So the radius would be 8 here. I'm going to take area equals radius, which is 8 squared times pi. 8 times 8 is 64, or 8 to the second power is 64. This is my exact answer. I pick up my calculator and take 64 times the pi button, and I get about 201. You'll see me putting the 0.0 there just to show you that that's how this one rounded, meters squared. So that is how you find the circumference and area. We did this in 7th grade. I hope that got sort of some of that back for you today. So now there will be a worksheet that you can just do a little bit of practice to make sure you remember, so that the next time we meet and we're talking about finding the volume of a cylinder, you'll remember what volume is and you'll remember how to find the area of a circle. Have a great day, everybody.